we had a question on section 8.2, number 21, r equals cosine 5 theta. So first I'm just going to figure out what type of curve is this. The main thing I want you to leave this class with is just kind of familiar with the shapes. Maybe not an expert at these curves, but if you're familiar with the shapes, that will help you in calc. So what shape is this? So we learned that if we have cosine n theta or sine n theta, we get rose curves. And this one will have 5 petals with the coefficient of 5. So just knowing the shape will help give me some guidance. So now what we want to do is we want to plot some points. And so normally I like to go 0, pi over 2, right? So on count by pi's over 2. Since we have a coefficient, we're going to divide by that coefficient, and we're going to count by pi over 10s. So 0, r, so we get 0, pi over 10, 2 pi over 10 would be 5, I am struggling. 2 pi over 10 would be pi over 5. 3 pi over 10, just counting by tenths, there just happens to be a pi. 4 pi over 10 would be 2 pi over 5. And then let's do 5 pi over 10 is pi over 2. And then if we need more points, we'll add more points, but for now, we'll stick with this. All right. So I am going to draw a polar graph. And what I'm going to estimate what pi over 10 would be. So pi over 10 is just some small angle. 2 pi over 10, 3 pi over 10, 4 pi over 10. I'm basically cutting the top half into tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Just to help us estimate the angles. It doesn't have to be perfect. But that will help us visualize it a little better. And then we have like a radius of 1. I'm just making a makeshift polar graph. So let's start plugging in. So we're going to plug into r equals cosine 5 theta. So the first one will just be cosine of 0, which is 1. The next one will be cosine of 5 times pi over 10, which is cosine of pi over 2, which is 0. So all of these should be, by counting by pi over 10, by using this trick, we'll get angles that should be easy on the unit circle. So then we'll do cosine of 5 times pi over 5, so that's cosine of pi, which is -1. Let's try a couple more. So cosine of 5 times 3 pi over 10, we get 3 pi over 2, which is cosine of 3 pi over 2 is 0. So try the next two. Maybe pause the video and see if you can do the next two without me. So if you've tried them, I think I get cosine of 2 pi, which is 1. And I get cosine of 5 pi over 2, which is 0. 5 pi over 2 would be right here. So it's the same as pi over 2. So let's plot these and see what happens. So let's see, let's do colors. So we're going to do 0, 1. So 0, 1 will be angle of 0, and we stop at 1. And then it looks like it comes back to 0 by pi over 10. So back to 0 is the origin, and so it's going to make a circular motion, and it's going to come in before the angle pi over 10. So it looks like it's making half of a petal. And then from 0, we're going to go to pi over 5, and then we're going to reflect because it's negative. So we're going to be on the opposite side, and we're going to reflect. And so it's probably going to come out, everything is circular motions, and it comes out to -1 for pi over 5, so the opposite side. And then it's going to come back in, and that's what makes it 0. And then we have 2 pi over 5. So this was 3 pi over 10, 2 pi over 5, or 4 pi over 10, if that helps. And so at 2 pi over 5, it's going to go back out to 1, so it's probably going to make another loop. And then it comes back to 0 before pi over 2. So I'm kind of starting to see the shape. It looks like I have about half of it. So I'm probably going to have to do a couple more angles. So we're going to go by pi over 10s. So this was 5 pi over 10 as a reminder. So the next one would be 6 pi over 10, which is 3 pi over 5. 7 pi over 10, 8 pi over 10, which simplifies to 4 pi over 5, 9 pi over 10, and then 10 pi over 10, which is pi. So we'll find out that stopping at pi is usually far enough. So why don't you pause the video and find these values? I'm just going to go ahead and tell you them. Since this is homework, maybe you can get some practice. So pause the video so you can try these without me. But otherwise, for the 3 pi over 5, we get cosine of 3 pi, which is -1. For the 7 pi over 10, what is that? Cosine of 7 pi over 2, which is 0. Cosine of 5 times 4 pi over 5 is cosine of 4 pi, which is 1. You might be noticing it's making this nice pattern, 0, 1, -1, 0, so on. The next one, we get cosine of 9 pi over 2, which is 0, and then for pi, we get cosine of 5 pi, which is -1. So let's see. I like these colors better. So now, by for 3 pi over 5, so this is pi over 2, 3 pi over 5. We're going to go to -1, so we'll again reflect to the opposite side. And, oops, I don't want that to red line. And it'll, again, make a petal. And then it's going to come back. The 0 is what's telling us it's coming back. All right, and then the next one, let's see. We're going to go to 4 pi over 5. So this was 7 pi over 10, 4 pi over 5. And we're going to go out to 1. So it's going to go out to 1. And then it's going to come back before 9 pi over 10, which is right here. I don't know where that line came from. I must have, this line. I must have changed it on accident. Comes back. And then it looks like for the final one, it goes to pi, which is right here. And it reflects, it goes to negative. So that's where it's finishing up that loop. And so you can kind of guess the shape a little too once you have most of the petals. So hopefully that helps. It was a tricky one. The angles are hard because we don't typically go by pi over 10s.